Hi, today we are looking at section 9.5, which deals with conics. So we are going to look specifically at graphs of circles and ellipses today. So first we'll talk about what types of shapes we get with conics, and essentially various shapes we get when we take this double cone and slice it. So if I was to slice perfectly horizontal across cone, let's just do in a different color. If I was to, let's say, slice perfectly horizontal across this cone, the shape we end up getting in that case would be a circle. Where if, for example, if we were to slice it on, let's say, an angle, like let's say an angle like this, we get a slightly different shape. We would end up with the shape of an oval, which in mathematics terms is referred to as an ellipse. Now, if we cut it on a bit more of an extreme angle, something like this, the shape we end up with, if we cut it like that, we end up with a shape that looks like this, which you should be familiar with from grade 11 math, which is a parabola. And the last thing we end up with is if we were to cut it vertically, so something like this, we end up with something known as a hyperbola. So this one, if you cut it that way, we'd end up with what essentially looks like two parabolas opening in opposite directions. Now, we are only going to really focus on these first two. If you take a different stream of mathematics, you will also look at other ones. So we'll be focusing on the graphs and equations of circles and ellipses. So if a circle essentially has an equation x minus h squared plus y minus k squared equals r squared, where h comma k is the center of a circle. So if I have a point here, that's h comma k, that's the center of our circle. And then r is our radius. So if we're given an equation in this form, we just figure out what our h is, where our k is, that's our center. And then we can go up by our radius, left by our radius, right by our radius, and down by our radius to graph. So for example, graph x minus 3 squared plus y minus, or sorry, y plus 2 squared equals 25. Now, technically, this gives us an h of 3, and this gives us a k of -2. So we know our center is at 3, -2. So we'll plot that. And then we know this is our r squared. So we're going to take the square root of 25, which is 5. So that's our radius. So I'd mark 5 above, 5 to right, 5 below, 5 to left, and then roughly draw in our circle. So this is roughly the circle described by this equation. Now we can also work backwards. If we're given an equation, we can a graph, we can come up with our equations. Our first thing we do is figure out where the center of our circle is. So looking at this, I would probably find the highest point and lowest point. We know that our center will be on that line. And then furthest left, furthest right. So we know that our center is right here. Now, look at this. We've got an x value of -1, 2, 3, 4. And a y value of 3 here. So this is our h value. This is our k value. And then we want our radius. So if I go just horizontal, I've got 1, 2, 3, 4, 5. So our radius is 5 in this case. So remember that our equation takes the form of x minus h squared plus y minus k squared equals r squared. So we have x minus -4 squared plus y minus 3 squared equals 5 squared. So we'll go through and simplify this a bit. We've got minus a negative, so that becomes positive. So we've got x plus 4 squared plus y minus 3 squared equals 25. So that would be the equation of this circle. So next we're going to look at ellipses. So they're very similar. Our equation is very close with a couple small differences. So ellipses have an equation of x minus h squared over a squared plus y minus k squared over b squared. And they equal 1. Where h comma k is the center, 2a is our horizontal chord length, 2b is our vertical chord length. Our longer chord is our major axis. While our shorter chord is our minor axis. So I'll quickly draw out an ellipse and label some of the stuff in it. So if, let's say, we have this ellipse, and let's say that this is our the center of ellipse. This is just like a circle, coordinate h comma k. Now, the horizontal distance from here to here is a. Horizontal distance from here to here is a, which is why our longer chord is, our horizontal chord length is 2a, because we've got a plus a giving us that 2a. Where our vertical distance from center to outside is b, and because we've got from center up and center down, the distance is 2b. So when we come up with this equation or are given this equation, essentially the square root of what's in our denominator is the distance from the center to a horizontal end if we're looking at A, and if we're looking at B, it'd be the distance from the center to a vertical maximum or minimum. And then it's always going to equal 1. So our first example, graph x minus 5 squared over 16 plus y plus 2 squared over 49 equals 1. So first thing I would do is mark the center. So we know our h from this is 5, and our k value is -2. So x value of 5, we're down at -2. Now, we know that the 16 is our a squared. So we know a squared equals 16. We'll take the square root of both sides. So our a is equal to 4. So that means we go 4 units horizontally in either direction. Now this is our b squared term. So we know 49 is equal to b squared. We'll take the square root of both sides. So we have 7 is equal to b. So we'll go up 7 units as well as down 7 units. And then we'll roughly sketch in our ellipse. So we can see that it would look something like this. Okay, so next we'll look at coming up with equation of an ellipse. So first thing I would want to do is find where the center of this ellipse is. Now we haven't been given a scale on this graph, so we're assuming every box is equal to 1. So this here, we have an x value of 1, 2, 3, 4. Well, we have a y value of 1, 2, 3, 4, 5, 6, 7. So we have our h and k right here. Next, we want to know our vertical distance. In this case, that's 3. So that's our b value. And we also want to know our horizontal distance. So that's 1, 2, 3, 4, 5. So we know our a value is 5. So we have the equation of the form x minus h squared over a squared plus y minus k squared over b squared equals 1. So we've got x minus 4 squared plus y minus 7 squared. And our x minus 4 squared is over a squared, so over 5 squared. Y minus 7 squared is over b squared, so over 3 squared equals 1. We'll simplify this. So we've got x minus 4 squared over 25 plus y minus 7 squared over 9 equals 1. And this would be our equation of this ellipse.